This is problem number 3 from the Chapter 11 review packet. Let me start off with, I'm going to look at this shape. Because of all the symmetry involved in regular polygons, I know that this angle are both 135 degrees. Since these sides are congruent to each other, and again with the fact that it's a regular polygon, I know that this angle will be congruent to this angle. 360 degrees inside of that quadrilateral. If we've used up 270, there's 90 degrees left to split, so they're each going to be equal to 45 degrees. We could do the same thing on other quadrilaterals like that. And what that tells us is that this is a 45-45 90 triangle then. And here's where I'm going to insert the temporary variable. I'll call this length x. It means this length is also x. I have a lot of x's in here. And also on the 45-45 90 hypotenuse would be equal to x root 2. So each side of the polygon is equal to x root 2. Let's go to the problem. What percentage of the figure is shaded? Percent shaded is equal to the area that's shaded divided by the total area. The shaded area is the area represented by that square or rectangle in the middle divided by the area of the octagon. Now if you look at this shape in the middle, I know that I have all these right angles in here, so it's at least going to be a rectangle. Since this length is x root 2, this is also x root 2. Since this is x root 2, this is also x root 2. So in fact, it is a square. The area of that square is x root 2 times x root 2. And we multiply x root 2 times x root 2. X times x is x squared. Root 2 times root 2 is 2. There's the area of the shaded part. Now to find the area of the entire octagon, we can use the fact that it's a regular polygon to do 1/2 times our perimeter, 8x root 2 if we add up all of those sides together, times the apothem. Now here is the apothem. It's going from the center, going to the midpoint of one of those sides. The length of that segment is going to be x for this part of it, and not quite a whole x root 2, but x root 2 divided by 2. So the apothem is x plus x root 2 divided by 2. And we want to multiply this out and simplify it for the area of the octagon. 1/2 times 8, we can simplify that and call that 4x root 2, and then distribute this value to both of the terms inside of those parentheses. So 4x root 2 times x is 4x squared root 2, and 4x root 2 times this. So 4 over 2 is going to simplify to 2 over 1, and then root 2 times root 2 is 2. 2 times the 2 that's already there is another 4, and then this x times that x is x squared. So when we find the area of the octagon, it can be represented by this. 4x squared root 2 plus 4x squared. Unlike a lot of the other problems we're doing where we're dealing with these similar shapes, we can work the variable out of there. In other words, we can divide everything by x squared, so it will simplify everything. We can also divide everything by 2, which would give us 1 over 2 root 2 plus 2. So there is our exact answer. And then we go to the calculator and get the approximate answer. That's approximately 20.7%. For problem number 4, we're again asked to find the percentage of the figure that's shaded. So our standard formula is that percent shaded is area shaded divided by area total. The shaded area is represented by the area of the regular triangle. The total area is the area of the regular triangle plus the area of the isosceles right triangle. We're going to insert a temporary variable, and this time I'm going to use a temporary number. It serves the same purpose. I'll say that this length is equal to 6. I could have chosen 4, I could have chosen x, I could have chosen 3x. I chose to use 6, and then as long as we simplify things down at the end, we'll have the correct exact answer. So the area of that shaded triangle then would be 6 squared root 3 over 4. And then if we simplify that down, it comes out to 9 root 3. So there is our numerator. The denominator has the area of that regular triangle again, which we just found out was 9 root 3, plus the area of this isosceles triangle. So this length is 6, and this length is 6 also. And in a 45, 45, 90 triangle, going from the hypotenuse to the leg, we get smaller, we divide by root 2. And if we rationalize that, we get 3 root 2 for the length of that side. So then the area of that isosceles right triangle is 1/2 times base times height. In other words, we're going to square this number, which is 18. 18 times 1/2 gives us a value of 9. So here is our exact answer. Not yet simplified though, because once again, we can work our way down. The fact that we use 6 is why we have all these 9s in here. If I divide everything by 9 now, you get root 3 over root 3 plus 1. So there is our exact answer. And then the approximate answer is about 63.4%. This is problem number 5. And we're told that the area of the circumscribed circle is 64 pi. So we're going to draw in this auxiliary segment, which would be a diameter of that circumscribed circle or a diagonal of that square. And since the area of this big circle is 64 pi, it means that the radius of that big circle is equal to 8. If that length is equal to 8, then the entire diameter would be equal to 16. And then as we look at this square, 16 is the hypotenuse of that 45, 45, 90. So 16 divided by root 2 will tell us that this length is equal to 8 root 2. And that's the length of one side of the square. And as we work that back, that means that this length would be equal to 4 square root of 2 because it's half of that length. And that is the radius for that inner circle. So the area of that inscribed circle then is pi times this radius squared. 4 squared is 16, root 2 squared is 2. So the exact area then would be 32 pi. 32 pi is approximately 100.53 units squared. This is problem number 6. We have a dog on a leash. We need to figure out the amount of area the dog can cover. The dog is going to be on the leash, can reach a certain distance in this direction, but because the leash is only 10 feet, the dog can't make it all the way to the corner. However, the dog can swing over in this direction, and once we get to that spot, the leash is going to change. The radius on the area is now going to be 6 feet rather than 10 feet because of that 4 feet that's being taken up, and then this is going to give us another quarter of a circle. So the different shapes that we have, this quarter circle is 1/4 pi times 10 squared, 3/4 pi times 10 squared, plus this quarter circle down here, that's 1/4 pi times 6 squared. This is 75 pi, this is equal to 9 pi. Add those together, you get 84 pi, and that is approximately 263.89 square feet. This is problem number 7. We have to find the area of this trapezoid. That's the average of the bases. 12 plus 16 is 28. 28 divided by 2 is 14. The area of the trapezoid is the average of the bases times the height. We'll draw in this height, and we'll also draw in this height. This segment in the middle is going to be 12. That leaves us with 4 units left to split amongst the left and the right. Each one of these little lengths is going to equal to 2. And what that allows us to do then is to work on this triangle. This is the height of the trapezoid. In order to find that value, we're going to take the tangent of 70 degrees, so that's equal to the opposite divided by the adjacent. So then the value of 8 times the tangent of 70, that is the height of this trapezoid. We get an exact area of 28 times the tangent of 70 degrees, and that is approximately 76.93